Here are the answers for the section 4-5 homework. This is day 2 of this section. Starting on page 138 with the evens, we're asked to factor the polynomials. This is a two-step process. Step 1, look for a greatest common factor. Step 2, look for a special pattern. In question 2, there is no greatest common factor, and this does not fit one of our special patterns. However, it is a factorable trinomial using FOIL. So two sets of parentheses, x times x is the x squared. Then for these two numbers, we want a pair of numbers that multiply to positive 3. Let's consider possibilities. 3 times 1 is positive 3, and negative 3 times negative 1 is positive 3. Looking at the middle term, we want our numbers to combine to negative 4. So that's this choice. Fill in the minus 3 and fill in the minus 1. Number 4, there is no greatest common factor, and this is not a special pattern called a perfect square trinomial, but it will factor using FOIL. So two sets of parentheses. N times n is our n squared. Now think of possibilities that multiply together to make 24. Looking at the middle term, we see that we want our numbers to combine to negative 11. So let's consider only the negative possibilities. One pair of numbers that multiplies to positive 24 is negative 8 times negative 3. There are more pairs, but this is the pair we want because these two numbers combine to negative 11. So fill in minus 8 and minus 3. Number 6, this is not a perfect square trinomial, but we can factor it using FOIL. M times m is the m squared. And now we need two numbers that multiply to negative 14x squared. Both of them will have an x in them. Now let's think about how we can multiply to negative 14. Possibilities are 7 times negative 2, negative 7 times positive 2, and there's more. But let's see if either of these gets us negative 5 when we combine the numbers. That would be this choice. Negative 7 plus 2 makes negative 5. So fill in the minus 7 and fill in the plus 2. Number 8, there's no greatest common factor, and this is not the special pattern called a perfect square trinomial, but we could try factoring using FOIL. Y times y is y squared. Now we need two numbers that multiply to negative 30. One possibility is 6 times negative 5. Another possibility is negative 6 times positive 5. There are more, such as 15 times negative 2 or 30 times negative 1, but let's see if either of these is correct. We want to combine to negative 1. That's this choice. Negative 6 plus 5 is negative 1. Fill in the minus 6 and fill in the plus 5. Number 10, there's no greatest common factor, and it's not a perfect square trinomial. But let's try factoring the trinomial with FOIL. T times t is t squared. Now we need two numbers that multiply to negative 72. One is 9 times negative 8, or negative 9 times positive 8. 9 and negative 8 combine to 1, and negative 9 plus 8 combines to negative 1. Neither of those is correct. We're trying to make negative 14. Let's think of another pair of numbers that multiply to 72. 18 times negative 4 is negative 72, and so is negative 18 times positive 4. These two numbers combine to 14, and these two combine to negative 14. And it's that last pair of numbers that we want. So fill in minus 18 and positive 4. Number 12. This polynomial is not in standard form. It doesn't have the highest degree term first and count down to the constant. Let's use the commutative property and rearrange the terms. Next, because it has a negative leading coefficient, let's factor out a negative sign. That leaves us x squared minus 5x minus 36 inside the parentheses. Now let's factor that trinomial. Here's the negative sign, and now the two sets of parentheses. X times x is x squared. We want two numbers that multiply to negative 36. 9 times negative 4, or negative 9 times positive 4. There are more choices, but let's see what these combine to. 9 and negative 4 add up to 5. Negative 9 and 4 add up to negative 5. It's this pair that we want because this term is a negative 5x. So fill in the minus 9 and the plus 4. Number 14 is also not in the correct order for standard form. So let's write the 9s squared first, then the negative 12s, and then the positive 4. There's no greatest common factor other than 1, but this might be a perfect square trinomial because the first term looks like a perfect square, and so does the last one. Let's check to see if it is. The square root of 9s squared is 3s. The square root of 4 is 2. 3s times 2 is 6s, and twice 6s is a 12s. So this is a perfect square trinomial pattern. One set of parentheses, squaring on the outside. 3s, 2, and a minus sign in the middle. Number 16, there is no greatest common factor other than 1, and it's not a perfect square trinomial. Let's try FOIL. This time the leading coefficient is not a 1. So to make 3n squared, we need 3n times n. Now we need two numbers that multiply to negative 8. There are possibilities. 8 times negative 1, negative 8 times positive 1, 4 times negative 2, negative 4 times positive 2. We can't simply combine these together to try to make negative 10 because the leading coefficient is 3, and that is involved in the outer product. Remember that the outer and inner products from FOIL are what combine to negative 10, not simply just the numbers we put in the last positions. Let's think about what pair of numbers to pick, as well as which position to put each of the numbers in if we want to create negative 10n. If we put some thought into it ahead of time, we can save a lot of wrong choices and having to erase. I noticed that some of my numbers involve a 4 and a 2. And if I put the 4 here and the 2 here, I have an outer product of a 12n and an inner product of a 2n. And if I subtract those, 12n minus 2n, I could get a 10. I just need the signs to work out. So I'm going to put negative with the 4 and positive with the 2. Here's what happens when we do that. 3n times negative 4 is negative 12n. 2 times n is positive 2n, and these combine to negative 10n. And that's what my middle term is. So here's the correct factored form. If we had made a wrong choice, we would simply erase those numbers and try them with the opposite signs, or try them by putting the 4 here and the 2 here. And if that had not have worked, then we would have tried using the 8 and the 1. Number 18, there's no greatest common factor other than 1, and it's not a perfect square trinomial. Let's try FOIL. We have some choices of numbers that multiply to make 12x squared. One possibility is 12x times 1x. Another possibility is 6x times 2x. And another possibility is 4x times 3x. Let's choose one of these and fill it in. If we find out later it doesn't work, we'll erase it and try a different pair of numbers. I'm going to try 4x and 3x. Now we need a pair of numbers that multiply to negative 15. Again, we have choices. 15 times negative 1. Negative 15 times positive 1. 5 times negative 3. And negative 5 times positive 3. Let's choose one of these pairs of numbers and fill it in. Then we're going to figure out the outer and inner products to see if we can get them to combine to negative 8x. I'm going to choose positive 5 with the negative 3. 4x times negative 3 is negative 12x. 5 times 3x is 15x. These combine to be 3x. That didn't work. And it's not going to help me just to switch those two numbers and put negative 5 here and positive 3 here, because all that would do is make our combination be negative 3x. Maybe we should not have used 4x and 3x to begin with. Let's erase those and try a different pair of numbers. Maybe 6x and 2x. Now let's do our outer and inner products again. 6x times negative 3 is negative 18x. 5 times 2x is positive 10x. These add together to make negative 8x. Hey, we lucked out. On our third try, we got the right combination of numbers. So our factored form is 6x plus 5 times 2x minus 3. Number 20. There is a greatest common factor. All three of these numbers divide by 3. So write that down and then make a set of parentheses following. 3 times 6y squared makes the 18y squared. 3 times negative 7y makes the negative 21y. And 3 times negative 3 makes the negative 9. Now let's try to factor this trinomial farther. Here's the 3, and let's make 2 sets of parentheses. There are possibilities to make 6y squared. It could be 6y times y, or maybe it's 3y times 2y. Let's choose one of these to fill in the parentheses, and if we find out later it doesn't work, we'll erase and try again. Let's try the 3y and the 2y. And then choose one of these pairs of numbers to fill in. I'm going to try this first pair of numbers, but I'm not going to put the 3 in this parenthesis and the negative 1 over here, because if I put a 3 in here, there would be a greatest common factor of 3 in those parentheses, and I've already taken care of greatest common factor. So I'm going to put the negative 1 here and put the positive 3 over here. Now let's find our outer and inner products. 3y times 3 is 9y. Negative 1 times 2y is negative 2y. And these combine to 7y. We want to make negative 7y. So we simply have the wrong sign. We need to switch the signs on our 1 and our 3. We want this one to be the positive 1. And we want this sign to be negative 3. Now the outer and inner products will work out. 3y times negative 3 is negative 9y. 1 times 2y is positive 2y. And these combine to negative 7y. Here's our factored form. Number 32 is not in standard form. The terms are not in the right order. So let's rewrite and put them in decreasing order. There is a greatest common factor. All of the terms can be divided by y to the third power. Y to the third times what makes y to the fifth? We need y squared. Y to the third times what makes negative y to the fourth? We need a negative y. Y to the third times what makes positive y to the third? We need a plus 1. Now let's inspect this trinomial. Is it the special pattern called a perfect square trinomial? It might be. The first term is a perfect square. Its square root is y. The last term is a perfect square. Its square root is 1. Let's check the middle term. Y times 1 is 1y, and twice that is 2y. But that does not have a 2y, so it's not a perfect square trinomial. Maybe it factors using FOIL. Let's try that. Y cubed, and then the 2 sets of parentheses from FOIL. y times y is the y squared. Now, what pairs of numbers multiply to positive 1? Noticing that the middle term is negative, we only need to consider negative numbers. Negative 1 times negative 1 makes positive 1. But these combine to negative 2, and that does not fit the middle term. What this tells us is this trinomial does not factor. So cross out this extra work we did. This is our final answer. Number 36. There's no greatest common factor, but this does fit a special pattern. This is a binomial and it's a difference. So we're checking to see, is it a difference of squares or is it a difference of cubes? This is a real interesting one because it's both of those. Z to the 6th power is a perfect square. Z to the 3rd squared is Z to the 6th. And 64 is a perfect square. The square root of 64 is 8. However, they're both also perfect cubes. The cube root of Z to the 6th is Z squared, and the cube root of 64 is 4. So because they fit both special patterns, it's our choice which one we want to use. I'm going to use the difference of squares pattern, which involves 2 sets of parentheses. Z to the 3rd times Z to the 3rd is the Z to the 6th. Positive 8 times negative 8 is the negative 64. Now inspect both of these. Are they special cases? Yes, they are. This is a sum of cubes. This one's a difference of cubes. The cube root of this is Z. The cube root of this is 2. The same over here. The cube root of that one is Z, and the cube root of that is 2. Let's follow the pattern for factoring a sum of cubes. It's a small set of parentheses and then a longer set of parentheses. Then let's follow the pattern for the difference of cubes. It's a smaller set of parentheses and a longer set of parentheses. Let's work on the sum of cubes first and fill in those 2 parentheses. Here's the Z and the 2 and the positive sign. Then square the Z. Change to minus, take the product of these 2 terms, and square the 2. Now focus on the difference of cubes. Here's the Z and a minus and a 2. Now let's fill in this trinomial. Square the Z, switch to plus, take the product, and square the 2. So this expression is our factored form of the original problem. For the review assignment, we're going back to page 135 and doing number 26, but we were still doing factoring at this point in time. This is where we learn to look for a greatest common factor and then a special pattern. This does not have a greatest common factor, but it is a difference of cubes. The cube root of 216 is 6. And the cube root of Z cubed is a Z. The parenthesis pattern for a difference of cubes is a small set of parentheses and then a longer set. Fill in those cube roots that we had figured out, the 6 and the Z. Put a minus sign here to match this sign. Then square the 6. Change to plus, take the product of our 2 roots, put a plus, and square the Z. Next is page 134. Again, we're factoring. These 2 terms have a greatest common factor of 3. 3 times what is 3a? We need an a. 3 times what is 3b? We need a positive b. Number 8 is a difference of squares. The square root of y squared is a y, and the square root of 81 is a 9. The parenthesis pattern for difference of squares is 2 sets of parentheses. Y times y and positive 9 times negative 9. Number 10 is also a difference of squares. The square root of 9a squared is 3a. The square root of 4 is a 2. So let's fill those into the parentheses. 3a plus 4 3a minus 4. Number 14 is a difference of squares. The square root of the first term is 7c. The square root of the last term is 6d. Let's fill those into the parentheses. 7c plus 6d, 7c minus 6d. Number 20 is not a binomial, so it can't be a difference of squares. Let's see if it's a perfect square trinomial. The square root of this is x, and the square root of this is 5. The product of this is 5x, and twice 5x is 10x. This is a perfect square trinomial. One set of parentheses, squared. Fill in those square roots that we figured out, and put a plus sign in the middle to match that plus sign. Number 24 is also a perfect square trinomial. The square root of the first term is 3b, and the square root of this is 1. And the middle term is twice the product of 3b and 1. So one set of parentheses squared. Fill in the 3b and the 1.